So let's get on with the next step, which is solving inequalities, which is where we'll use actually this factoring business that we just looked at. So compare actually these two exercises. So exercise 1 would be solving a very simple equality, 1 over x equals 1. And exercise 2 that we'll have a look at is solving a fairly simple inequality, 1 over x is smaller than or equal to 1. Well, they look fairly similar, but let's actually check whether they are. So let's first have a look at this equality, 1 over x equals 1. Well, if you need to solve that, of course, the first thing that you want to remark is, well, this does not make sense if x equals 0, because then we would be dividing by 0, and we can't have that. So we have to impose this condition, x is not equal to 0. So once we have that, what would we do? Well, we would say, oh, 1 over x equals 1. Let's just multiply both sides by x. So that means, or cross multiply actually, both terms by x and by 1 if you wish. Let's reduce to x equals 1, no surprises there. This is an easy example. So, right, 1 over x equals 1, let's solve by saying, oh, x should equal 1. No problem. Now consider the second exercise. So again, 1 over x smaller or equal to 1. How should we solve this? Well, again, first we remark, oh, x is not going to be allowed to be equal to 0 because we're dividing here by x, and we cannot, or we do not allow to divide by 0. So should we solve this sort of in a similar way? Well, let's again multiply by x on two sides. So we have on one side the x, on the right side we have the x, going to be bigger than 1. Well, to some extent that's true. If x is bigger than 1, indeed, then 1 over x is smaller than 1. But it's the truth, but it's actually not the whole truth. So it's wrong in mathematics. It's wrong because if you look at, for instance, the value of x equals minus 1, well, that actually also fits this expression, right? 1 divided by minus 1. How much is that? That's minus 1. Sure, that's smaller than 1. So we didn't find x covers x bigger than 1. The stuff that we found does not cover all the solutions. So the basic rule here is if you are solving some inequality, it's just not allowed to just multiply it by a variable. We have to do something with the variable here being x. We have to do something actually slightly more tricky. So we're going to do that. That's slightly more tricky here on the next slide, and I'll do it on paper actually. So what we're going to do is, well, of course, first mention what those conditions are, like x should not be equal to 0, etc. Then we're going to move the terms to one side and factor, and use our factoring abilities that we just practiced to actually factor that side. Then we'll figure out for what variable are some of the factors going to be 0, because that's then going to allow us to draw some conclusions about the product or the quotient of those factors. So let's, rather than talk about this, just do it and actually do it on paper. And of course, it will also be on your slide. So let's go to the paper. So we have 1 divided by x is smaller than 1. We first note, as we just did before, x is not going to be allowed to be equal to 0. That remains exactly the same, so that's we can divide by 0. But what should we do now? We cannot just go ahead as we did before. We now want to sort of, as I just said, move all stuff from the right hand side to the left hand side. So what does it give us? This is going to be equivalent with saying, well, it means that 1 divided by x minus 1 should be smaller than or equal to 0. So what do we have here? We have a difference of two terms. A difference of a fraction, actually in this case, a number. What we want to do is to convert this difference of terms into a product or a quotient of factors in a regular fraction. So that's what we want to do. We want to factorize this left-hand side expression. So how should we do this? Well, if we factorize a fraction, we need to make sure they have the same denominators. So let's write this as 1 over x minus x over x, which is just multiplying both the numerator and the denominator, which was a 1 basically, right? X over x equal to 1, obviously, provided we are under this condition that x is not equal to 0. To be smaller than 0. Now again, we are in business. We have difference of two fractions with the same denominators. Denominators are x in both cases. So we can rewrite that as 1 minus x divided by x is smaller than 0. So this is something that we can handle. So how do we handle this? Well, the first step that we take is, well, there's here two factors, 1 minus x on top in the numerator. There's one factor in the denominator, which is x. And we first have to figure out, what are the special values here? And special values are those where one of those factors equals 0. So for the numerator, x equals 1 is this special factor. And for the denominator, x equals 0 is this special factor. So what we're going to do now, and that's basically building a sign diagram, is we're going to draw basically the number line, and we indicate on this number line these special cases, the x equals 1 and the x equals 0 that we had. So x equals 0 would be here, and x equals 1 would be over here. And now we're going to explore the signs of these different factors in this fraction separately on each line. So let's first look at the first factor, which is the 1 minus x in the numerator. Well, of course, 1 minus x is 0 if x equals 1. So at this point, actually, it's 0. So what happens on the left and the right hand side? On the left hand side, so if x is smaller than 1, well, then 1 minus x itself is going to be bigger than 0. X is smaller than 1. 1 minus x is going to be bigger than 0, and bigger than 0 we draw in the sign diagram as a drawn line. On the right hand side we have x bigger than 1. Well, what happens to 1 minus x if x is bigger than 1? Well, then 1 minus x is going to be smaller than 0, right? On the right hand side we have here minuses. Here this expression, this 1 minus x is going to be negative. Same thing for the other factor, which was the x. So where was this x? 0? Well, x is 0 at x equals 0, of course. But what happens to the left side of this? Well, to the left side of 0, x is going to be negative. So there we have the dashed line, denoting that this is a negative expression. To the right hand side of 0, we're going to draw a drawn line, denoting, well, that this particular factor is going to be positive over here. So now we have identified the signs of the different factors, the 1 minus x factor and the x factor involved in this fraction, in the various areas that we can identify on the number line. Now we can actually use that information to look at what's this total fraction, the sign of this total fraction going to be. Let's have a look. So 1 minus x divided by x is going to be the quotient of 1 minus x, this first factor, divided by x, this second factor. Can we say something about the sign? Now recall, in this area over here, 1 minus x is positive, right? Drawn line. We're dividing by x, which in this area is negative, it's minus. A positive divided by a negative, well, that's going to be a negative. So to the left hand side of the 0, this whole expression is going to be negative. What happens at 0? Well, at 0 is something special occurring, namely x is going to be 0. Well, that was the denominator. And the denominator is never going to be allowed to be 0, right? That was our initial condition, actually. We'll actually denote that by a cross. A big cross means this is not an allowed value for x. We're dividing here by 0. Okay, the next bit will be the area between 0 and 1. Well, what's happening there? Well, the first factor, the 1 minus x, which is in the numerator, is positive. We're dividing by x, which is also positive. So a positive divided by a positive is going to be a positive, right? Next, add this special value x equals 1. What's happening? Well, the numerator is 0. Well, that's fine. You can have a numerator that's equal to 0. The denominator is just 1. 0 divided by 1, that's 0. But the numerator is 0, then the whole fraction is going to be 0. Now finally, we only have this region to the right of 1, so where x is bigger than 1. So what's happening? Well, the numerator expression 1 minus x is going to be negative here, right? So it's dashed line, negative. We're dividing by the positive denominator, so a negative divided by a positive, that's again going to be a negative. What we've now identified is what is the sign of this fraction that we were interested in by looking at the signs of the individual components, the individual factors in this fraction. So we see now when is 1 minus x divided by x going to be smaller than 0 or equal to 0? Well, smaller than 0 is happening over here, so for x is smaller than 0. X is smaller than 0 will work. There, this inequality will be satisfied. I should of course rewrite this as x is smaller than 0 because x equals 0 is not allowed. Slight mistake, that was the not allowed value, why we had a cross here. X is smaller than 0 will be one part of the solutions. This region, x equals 0 is not allowed. This region between 0 and 1, well, 1 minus x divided by x is positive, so it does not satisfy our original inequality. From 0 onwards over here, indeed, the whole fraction is going to be either 0 over here or negative, which is precisely what we want. So the other part of the solution is x is going to be bigger than 1 or 1 itself. It's bigger than or equal to 1. So the final solution basically to this inequality is either x is smaller than 0 or we sometimes write like this big T, x is bigger than 1. Two regions, x is smaller than 0 or x is bigger than 1. So this is a sign diagram way basically to identify where this fraction is smaller than 1. So let's go back to the slide. So here actually the same thing is happening. We factor this left hand side, and you see that actually happening over here. So we put everything to the left hand side. We rewrote it as a one fraction by putting things under the same denominator, namely this x. We looked at the special values for x equals 1 where the numerator is actually 0, or x equals 0 where the other factor, namely the denominator factor, is going to be 0. And then we build this sign diagram that I just did on paper. And we now have to solve this final expression. We just look at the answer in this bottom row here in the sign diagram. When is this expression smaller than 0? Well, in this area here where we have the negative signs, and also in this right hand area here where we have the negative signs. So the total solution is x smaller than 0 or also allowed x bigger than 1. So that's the total solution of this inequality. So you can again practice this by this exercise that we have here on the slide, and actually the answer this is at the end of this slide text, but just try this at home drawing this sign diagram. Okay, and we'll do this in the tutorial as well. Okay. So the next thing is we are going to look at quadratic equations.